Sometimes working with sheet metal in SolidWorks can be a little tricky, especially if you're trying to make complex shapes. Here's a neat way to make sheet metal spirals that can also unfold. To do this, I'll start with a sketch on the top plane. I'll sketch a 2-inch circle centered on the origin. And I can exit the sketch. Next, I'll go to Insert, Curves, and then select Helix and Spiral. I'll choose the circle sketch to start the curve. I'll define my helix by height and pitch, choosing a height and pitch of 4 inches. With this curve finished, I'll create a second similar curve. Again, I'll start with a circle concentric to the first on the top plane, but this time with a diameter of 4 inches. Using this circle sketch, I'll create a second helix keeping the same options. These two curves define the edges of my sheet metal part. However, I can't create the lofted bend just yet. This feature requires 2 sketches to create, but it cannot be made from curve features such as the helix. Luckily, this is a simple fix. I'll create a new 3D sketch. To convert the curves, I'll use the Convert Entities tool and select one of the curves. With the curve converted, I'll exit the sketch and repeat the process for the second curve. Now I have 2 3D sketches that contain the helix geometry. I'll launch the Lofted Bends feature from the Sheet Metal toolbar. I'll select the 2 3D sketches as the profiles. A preview of the part appears. I'll enter a thickness, and then I can go ahead and click the green check to finish the feature. Notice the flat pattern feature is suppressed at the bottom of the tree. If I unsuppress this, I can see my part flattened out. I can suppress it again to return the part to its bent state. I can also use the flatten icon on the sheet metal toolbar. Using helixes as 3D sketches is a cool way to make unique lofted bends. However, there are some limitations to this ability. For instance, what if I want my part to have more than 1 revolution? I'll go back and change both helixes to 8 inches instead of 4. This gives me 2 revolutions of the helix. Now if I try to flatten the part, I'll either get an error or just simply a sketch of the curves. This is because the part would have to stack on itself like a slinky in order to flatten. If I create the part this way, I'm limited to 1 revolution, or a pitch that is equal to or greater than the height. There's another way to approach this part that will give me a similar result. This time, I'll start with 2 sketches of identical concentric circles on the top plane. Once I have both of the sketches complete, I'll create a helix from the first one with a height of 4 inches and a pitch of 1 inch. This will create 4 revolutions of the helix. I'll create another helix out of the second one with the same options, except for this one I'll put an initial angle of 180 degrees. Just like last time, I'll again convert each one into a 3D sketch so that I can use them for a lofted bend. I'll go to Sheet Metal and click on Lofted Bends. I'll choose my 2 sketches and then click the green check. If I look carefully, I can see that I have a double helix. There are 2 separate ramps circling around each other. If I flatten this feature, you can see that I end up with a very long vertical rectangle. It's clear I would have to put a huge amount of stress on the part in order to deform it in such a way to actually make it, so be careful when designing using these techniques, as the part might not actually be manufacturable. However, both of these techniques are pretty cool ways to create sheet metal spiral models, and they give you the ability to flatten the parts.